This section's on multiplicative recursion, which is also known as geometric sequences. There's a formula that we're going to use that is written right here, and it is A sub n equals A sub 1 multiplied by r raised to the n minus 1 power. So what does that all mean? A sub 1 is the term you're looking for. Sorry, A sub n is the term you're looking for. So when we give you a list, like you'll see right down here, and it'll say that we want the fourth term, that is what your A sub n is. A sub 1 is the first term. R is the constant multiplier, also known as the common ratio. And then n minus 1 is the exponent that you're going to raise the r to. So let's take a look at the first example here. The series is 16, 20, 25, 31, and 25 hundredths. So what you have to do first is find the common ratio, the constant multiplier. And you're going to take the first two terms and you're going to divide the second term by the first term. So you're going to use your calculator and you're going to do 21 divided by 16 and you'll get 1.25. So 1.25 is your R. That's your common ratio. So what we're looking for is, we're going to look for the seventh term for all of these. So it's A sub 7. That's just telling you we want the seventh term. So now you're going to say, okay, I need the first term, which is 16, and that's right there. And that is going to get multiplied by that common ratio of 1.25. But now we have to raise that to a power. And the power here is n minus 1. So what does that mean? That means that we are looking for the seventh term. 7 minus 1 means we raise it to the sixth power. The reason that we're raising it to the sixth power is because this 16 is already written there. So we have 4 terms written out, and that 16 is taking the place of that first term, which means you're finding 6 terms past 16, which technically would be the seventh term. So on your calculator, you want to take 1.25 and raise it to the sixth power. And that's going to give you 16, and it's going to give you 3.814697266, but just go to the hundredths place. And then you're going to multiply that by 16, and you will get 60.96. So it's going to be much easier for you if you do this first and then multiply by 16. Let's take a look at the second one. We have 27, 18, 12, and 8. So the numbers are going down. We're going to look at these first two. We're going to take the 18 and divide it by 27. And our constant multiplier is 0.666. So it's 2/3. But we're going to round it, and that's going to be your R. So we take the first term, which is 27, multiply it by that constant multiplier, 0.67. And again, we're raising everything to the seventh term, so your exponent will be a 6. Take your calculator, 0.67, raise it to the sixth power, and you will have 27 times 0.09, and then multiply it by 27, and it's 2.43. So I'm going to have you pause the video, and I want you to try this next one on your own. Okay, so now we are going to look at the first two terms. 2 divided by 1 is 2. Your first term is 1. 2 raised to the sixth power. 2 to the sixth power is 64, times 1 is 64. Sorry, this is a little crammed in here. Now we're going to go to the next page, and I have some practice problems for you to do there. Okay, for these we're going to find the 8th term. So the first thing we have to do is divide these two. So our r will be 6 divided by 1, which is 6. Our first term, remember the formula is a sub 1 multiplied by r raised to the n minus 1. So we have 1 multiplied by 6 to the 7th power. So we have 6 raised to the 7th power, which is a very large number, 279,936. And then obviously if you multiply that by 1, that is going to be your answer. The next one we have 5 divided by 1, so your common ratio is 5. 1 times 5 to the 7th power. 5 to the 7th power is 78,125. Times it by 1 gives you that answer. We are finding the 8th term again, so we have 15 divided by 3 is 5. First term is 3. 5 raised to the 7th power, which is, back to that, 78,125. Multiply that by 3, and you end up with a final answer of 234,375. In your textbook on page 391, we did 1D, E, and F, and you can work on that.